Okay, I'm Stuart Mills. I am one of the founders of Dundee and part of the management team. I have lots of slides here, so I apologise if I rush a little. We're a UK limited company incorporated in 2002. You won't be surprised to hear we're based in Dundee. We also have an office in Barcelona, and we're management majority owned. We're well established with a worldwide reputation. Almost all of our sales are exports, with between 70 and 90% of our turnover exports to USA, China, Europe, all across Europe, Japan, Russia, South America, Africa. We're suppliers to all the major space agencies, all the global space industry. We've been profitable for each of our past 13 years. We're successful because of our people. We're a highly technical staff and outsource all our manufacturing. Over half of our staff are PhD qualified, and 90%, in fact in excess of 90%, are technical R&D. We're award-winning. We've won a number of awards over the years. These are some of them. Last year we were named Scottish Business of the Year for companies with less than 25 employees. The technology that our success has been based around is called SpaceWire. It's a computer network technology for onboard spacecraft. It connects together all the bits, the components of the spacecraft, the instruments, the mass memory, and it's a standard. It's a European standard that's used worldwide. And it's specifically designed for space applications. It's very simple, which makes it easy to implement, and it's also very high performance, far in excess of the previous standards before SpaceWire was standardized. And it's very flexible. It doesn't impose any restrictions on the network architecture. SpaceWire standard was written in Dundee by our managing director, well employed by the University of Dundee, so we're in a fantastic position to make use of that technology. It was written as a European standard with inputs from international spacecraft engineers, so people from all over the world contributed to this. It's now been used or designed into over 100 spacecraft, with over $25 billion worth of spacecraft relying on it. And our chip technology is designed into a lot of those space missions, be it European, Japanese, USA, and further afield. This is an image produced by ESA, just trying to show some of the ESA, JAXA, and NASA missions using SpaceWire. I've got some slides here with some images. This is Gaia using SpaceWire, Sentinel-2, ExoMars rover. SpaceWire is being used in robotics for the previous presentation. Bepi Colombo, both the European and Japanese parts use SpaceWire, and James Webb Space Telescope's using some very long SpaceWire cables. Quite a big thing. What we do is we offer chip designs and IP cores, so you can buy our IP and use it on your spacecraft. You can buy chips from our partners who incorporate our IP in their chips. We have interface and router devices. We have analysis tools for link analysis, conformance testing. We can do real-time instrument simulation in a day. All of our products come with comprehensive software and support. We support multiple platforms, and we also do flight chip development kits, so you can test out some of the ASICs which incorporate our IP. Basically, we provide everything you need to incorporate SpaceWire into your spacecraft. Our chip designs, we offer lots of different SpaceWire IP cores. They're used in various chips from Atmel. They've been incorporated into many spacecraft, and they're running in many different FPGAs. They're widely used across Europe, America, Japan, China, India, and a few other places. So that was SpaceWire, that was where we started off. Space Fiber is now what we're working on. We continue to support SpaceWire, we continue to develop it. The Space Fiber is something that we're now leading on. It's similar to SpaceWire, it's designed specifically for space use, but it offers much higher data rates and also lots of other capabilities that weren't present in SpaceWire. This means it's now possible to use it for AOCS and GNC applications as well as payload data handling, which was what SpaceWire was traditionally used for. As with SpaceWire, it reduces cost, schedule, and risk. It's easy to integrate with existing SpaceWire equipment because it offers the same packet-level interface, and it also offers integrated FDIR and quality of service support. We're already offering some Space Fiber IP cores, and we're working on a router which is due at the end of the year. Our space fiber IP is being incorporated into the RAM-on chip 64-core DSP, which will be available in the near future. We're also working on test equipment for space fiber. You can already buy the Starfire device. We have lots of partnerships. We've been partnershiping recently with Microsemi on their RTG4 FPGA for space use. This is a demonstration system we've been running across the world, running space wire and space fiber on the RTG4, and it's a very effective use of the RTG4, and it provides a lot of the features required for space fiber. We have lots of other areas of expertise. We've been working on a terahertz radiometer with RAL and some other partners, and that's now led to an FFT spectrometer called the WBS4, which the next revision, which we've secured funding for, will be based on the RTG4 that I've shown a couple of slides back. That'll be a space flight EM. To summarise, we're a successful space company. We have a worldwide customer base. We're focused on spacecraft onboard data handling. We're very innovative. We originated the spacewire standard. We continue to be the leaders. We're now originators of the space fiber standard. We plan to be leaders of both spacewire and space fiber in the long-term future. We're very trusted. We have leading expertise. We have lots of partners which allow us to make use of that expertise. Our IP cores are used in many space missions, and our test and development equipment is used by most space organizations. And we do that all and continue to generate business because of our first-class product support, and that's mainly due to the excellent people that we have. Thank you.